Hello, everyone. See you again, okay? This is a math elective. Hopefully, everyone's okay. Uh, we, Today, we're going to start the new lessons. When we finished our vectors, last lesson, last class, we finished vectors. That is a 2 by 2. We haven't learned 3 by 3 of vector yet. Maybe it should be next year. Otherwise, if we have time, if we finish everything, we can learn 3 by 3, the vector 3 by 3 for this year. But I doubt it may not have time. Okay, but see, whatever. Now we go for our next class, next lesson for math elective is a matrix. Matrices. This lesson, I believe all of you has learned before in grade 10, right? But now I will review a little bit more for the addition, subtraction, and some meaning of scalar multiplication of matrices. Okay, and then after we review this, we're gonna go for some question a little bit harder. Okay, but we review by matrix 2 by 2 first, the order 2 by 2. Okay, so now we start addition of matrices. Addition and subtraction are almost the same, just only plus, right? Just go for plus or subtract. But the main thing is here both of them must have the same order. What the meaning of same order matrix? Or can say should have the equality of matrices. Same orders mean for like right now we talk about 2 by 2, right? For example, same order, for example, matrix A, like a matrix A equal to like this. Maybe say can be any number, right? A, B, C, D. Inside here we call elements or entries. Okay, so each element. So and this one matrix A equal to A, B, C, D. So the order is what? 2 row, right? 2, we lead from this side is a row. If you lead down like this way, it's called column. So this one first row, second row. So we have the first one, we have 2 row, and the second, and when you lead the column down here, one column, first column, second column, then also 2, so 2 by 2. Okay, so matrix A and then matrix B should have the same order. That's the meaning. Okay, in this one, right? For example, A, B, C, D, maybe this one E, F, G, H, right? If this one again, we have 2 rows and 2 columns, so become 2 by 2. In this case, we can see this. There are this matrix A and B. They have the same order, correct? Mean 2 by 2 here. Then they can plus they can do addition or subtraction. They can add it up. So I think this one you know already. So how to do? Just do the first. Right now A is the first row, first column. Then for example, if we say we want to find matrix A plus B, we review, okay? So a little bit faster. So become the same location, correct? First row, first column of matrix A, and also first row, first column of matrix B. So you're gonna have A plus E, and then B plus F, okay? And then C plus G, and then D minus H. Sorry, plus. Okay, so this matrix A plus B will equal to this. So inside elements A, B, C, D, E, F, G, H can be any number. Can be any number. That means can be any real number. Can be decimal, can be third, can be fraction, right? Can be whole number, integer numbers. Okay, then we call this addition subtraction of matrices. So you can plus minus. If minus, you just say it matrix A minus B. You just become what? Instead plus become A minus E, right? And then so on. So become like this one. Become minus, that's all. Become A minus E. And then this C minus G like this. And B minus F. And D minus H. Okay, So this is the matrix additional and subtraction matrices. Now we have to, now what is the, I will explain a little bit more for this one. What is the, what they call, the equality of matrix. Equality of matrix. Equality of matrices. Okay, if we're gonna say these two matrices are equal, then they have to be exact, must have the exactly of the order and the element also. Each element, like this one, first say if A equal to element inside maybe A, B, C, D, and B must have the same A, B, C, D also. Just say this one, they're equal. These two matrix A equal to matrix B. This is the equality of matrix. Let's say if this one, for example, it say A is what? 1, 2, 3, 4, like this, right? And then B should have the same 1, 2, 3, 4. So we can say this is the equality matrix. Okay. So if assume this one have like a negative, and then this one this one not equal anymore. Even you have only one element different from the others. Okay, like this one become -1 and this one plus, and the rest still same. Then this one you can still can say this one not equal. Okay, so this is not equal. So this is a definition of equality of matrices. But when you're gonna do plus or addition or subtraction, have the same order, that's enough. This inside doesn't matter. The element doesn't matter, have to be equal. So that's the meaning of addition, subtraction, and equality of matrices. Now, so you can see from this addition, the property, from the definition for two matrices A and B of the same order must have the same order. Okay, the matrix A and A plus B is obtained by adding the corresponding element of A and B. Element that mean inside each element like a B, C, D. Okay, if you want to do subtract, so the same thing. So we can use this definition, subtraction by what? By subtracting, that's all. By change, addition becomes subtraction. Subtracting, that's one. Okay, so now we go for the scalar multiplication. What the meaning, okay? Scalar multiplications. Okay, we see scalar, that scalar is really similar to vectors. Okay, say for a matrix A and real number. Real number, that means can be any number on the number line. Can be decimal point, fractions, surds, integer number, whole number, right? That's the mean this one for K. So then in this case we call it a scalar. The matrix K times A is obtained by multiplying each element in A by K. Okay, this is a multiplication. So if, and we see this property first, if A, B have the same, if A, B have the same order, or this B should be capital B, sorry, should be big, the matrix represent matrix, so big B. Have the same order, then for any scalar H and K, we're gonna have K times vector A plus, K times matrix A plus B, and then you can expand by K A, matrix A and plus KB. And if we can say this one is, and then H plus K, right? So become HAKB, okay? And the last one gonna be HK, both of H and K is a number that we can call scalar. In vector, we call scalar also, correct? And then this one is can be S times K and times matrix A. Okay, so for this case, for example, like for example, if I have, say, assume, give example, what the meaning here, okay? Scalar, for example, say, if I give matrix A equal to maybe any number, maybe 2, 3, -1, 5, something like this, okay? So then 1 to 5, what? Assume question 1 to 5. This may just the easy one first, okay? So 5 to A, matrix 2A equal to 1. So in this case, 2 is a scalar, and A is a matrix. Same thing like in vectors. When you like two vector A like this, right? Two scalar, A is a vectors, have direction. So in this algebra, you accept to like this also, right? But matrix, for example, if scalar become fraction, like for example, you have 2 over vector A come back here. You have to write like this, right? If you write in this form, we just review, okay? Over 3 like this. So this one not accepted in vectors, even in matrix, the same thing. So matrix, you have to write it down, become 2 over 3 matrix A. You cannot, don't write in this way, same meaning, okay? So you have to write in this pattern. But in algebra, you can write both, right? Doesn't matter. But vector and matrix, you have to write the scalar separate from matrix and from the vectors. So this one accepted for vector and matrix of the writing. If this one long, okay? So that's with algebra, okay? Okay, now we come back to this. So if I want you find 2A, right? You just, this one gonna be what? Just 2 times inside the time, just expand time with the matrix A become 4, become 6, become -2 and 10, that's all. Okay, that's the meaning for like this one when you time in like a question A. When plus is really simple, right? Because the again if then in this case is, I think they call this one is commutative property, and this one is should be associative property, right? For this one. So this one can use in the logic also when you learn the math core for the logic lessons. Okay, only the different lighting. Now that is the meaning of scalar multiplication. Okay, actually scalar like a in general you can write 2A or A2 or A2 is okay, right? Because scalar can move around if their time. But when we write A2, it's not really normal pattern. So most of the time we write scalar in front of matrix or vectors. Okay. So now this definition of addition, subtraction, and scalar multiplication. Okay. So now I will go the next one for multiplication, more the idea of multiplication. Right? See some property of matrix multiplications. Okay. If we see on the ordinary algebra, we compare, okay, between algebra and the matrix. Okay, if say if the first one, okay, say if A and B are real number, so if we have A and B are real or belong to real number, okay, in this case we're gonna have A times B. It's okay, right? We have A, just say this one equal to A times B. If talk about multiplication, okay, let's now talk multiplication. But for the matrix, you have matrix A and matrix B here. If you want to multiply or multiply A multiply matrix B, this one gonna be what? AB, right? matrix A times matrix B. Also can do that way. But in the second one, if the second idea, then when you have A times B, this algebra, right? A, B is a number. So A times B gonna be equal to B times A, can be that way, right? But for matrix, you see, if A times B will equal to B times A or not? No, right? If they equal, have some cases, maybe a few percentage, but most of them not equal. Okay, they have some percentage, A times B equal to B times A, depend the number and the condition. But in general, matrix A times matrix B is not equal to B times A. Okay, they are not the same one. Okay, so why? Because when we talk about matrix, inside in the matrix we have some each element inside. For example, this one 2 by 2. Okay, and B have also. So when you have, for example, this is a A, maybe I give number. I can try number. Maybe say A is a 1, B is a 2, 3 is 4. Okay, and time matrix B, maybe 2, 3 minus 1, 4 like this. Okay, so then you can try if you have time, right? We're gonna learn how to multiplication, maybe next one. So you can try, this is a A, correct? This is a B. But if you use this one, B first, and 3 and negative 4 here, and then time with A here. So they won't be equal. They are not equal. So we can try. So remember, right, how to time first row time this. Okay. By this space, maybe we do this one later. Okay. How to time. Recall your what you learned before. Now go the next condition first. Number 3. If the number A times 0, they will equal to 0 times A. That means equal to 0. For this algebra, okay, correct, everyone accept. And then also 3, for the matrix, I mean, if we give this O is a matrix, okay, then and O times A, the matrix O times A, and it will equal to A times matrix A times matrix O, no? Because O, I gave this name as a 0 matrix. It's a 0 matrix. So in this case, come out gonna be equal to 0. Okay, so in this case, okay, they are for all of A, matrix A. Okay, this one have the same idea. Now the fourth condition, if say the number A times B plus C. Okay, this is a commutative property, you see. And then you're gonna have AB, right? A times B plus A times C. Then number for the matrix. For the matrix, you're gonna have A, for example, matrix A times matrix B plus C. So come out gonna be, become matrix A times matrix C. Okay. So I mean plus A times matrix C. But in this case, for algebra, if you like AB or you like BA time, or even you swap CA, it's okay, right? So you get the same answer. They're equal, correct? But for matrix, you can swap. You can swap from the condition number 2 here. Okay, you can swap this one. You can swap like that become BA plus CA or AC, whatever. Here, it's not the same. Okay, so you have to see which one is a prefix, which one in the front bracket. Then have to be on the front, like A in the front of this one should be A and B. A and C. Cannot swap become B and A. They are not the same because the element inside, each element, okay, even they have the same element here, but when multiplication, when you solve A, B, not equal to, it's not equal to B, A. Okay, now go on the next comparison of the multiplication, the idea of the algebra and the matrix, ordinary algebra. So for example, if you have A times 1, will equal to 1 times A, right? Okay, A, B, right now is a real number, okay? Don't forget this is a real number. And this one going to be equal to A, right? Now for matrix, 1 we're going to use as an identity. Identity, for example, if 2 by 2, okay, if 2 by 2, we're going to have 1, 0, 0, 1. This is a 2 by 2. And diagonal here going to be 1. You see that? This is a 1. This is the diagonal line, going to be 1. Okay. So in this is a 1. So in this case, matrix going to be a different form here, right? From algebra. So if, for example, we have identity matrix. This called identity matrix. Okay, I times A. Assume I identity is a 1, 0, 0, 1, and maybe just say A can be any number A, B, C, D, right? So okay, if we give this A, B, C, D, when you time it, right, they will become this one. Just say when you time it up, they will equal to the formula. This case I'm trying to say is when you have identity A will equal to AI. Okay, so when you time this one become A and this one becomes 0 to come out, which is equal to A. Okay, so this keep in mind. Identity times any matrix equal to any matrix times identity, which is be equal to that matrix. So when this come out, should be equal to A. Okay. So now this one keep in mind. This is one definition also. Okay, and this also in the case. Okay, some only a few percentage say this one can be equal, but in general, AB not equal to BA. Okay, so now see another cases. Last one say if A power n, okay, exists or for all A greater than and equal to 0. Okay, in this case, if you talk about the exponent, talk about the exponent, right, the power in this is A can be negative also, but right now we compare with the matrix only. So we compare when this case going to be exist when A greater than equal to 0. But in the matrix ideas, say in matrix A power n, okay, for n greater than equal to 2 can be determined by provided for the A. And this one can get it, right? But the A have to be what? A is a square matrix. A have to be square matrix and n belong to integers numbers. Okay, so they have their own condition in this case. A square matrix, what the meaning square matrix? Square matrix like a 2 by 2 should be 2 by 2 or 3 by 3, right? 3 by 3 mean 3 row, 3 column. 4 by 4, 3 row, 4 row, 4 column. So we call this is a square matrix. Okay, then just now we take a look already for the idea of the if we compare in the algebra, ordinary algebra, and the matrix algebra. This is the one, okay? And then we go next example. Then after this one, we can use the idea we just talked about here, okay? Next example. Or maybe this one, can I explain how to multiply here? We have some space here. So like this one come back, just recall about how to multiply, right? This is the first law. We get from here, number 2, okay, how to multiply. First row time first column of the B. This is a A. This is a B. This one first row, right? So when we want to time multiply matrix A time matrix B. Okay. So how we write down? Gonna be 2 times 1. This is the first row here. 2, and this is a column 2 times 1. So become 2 times 1. This times this, and then 3 times 3 plus 3 times 3. Okay. This first row, first column. Now first row with the second column. First row 2, 3, second column 2, 4. So 2 times 2. This one gonna be 2 times 2. And then 3 times 4 plus this is 3 times 4. This is 4, okay. Then close. Now we use next second row time with the first column. -1, 4 times with the 1, 3 here. So become -1 times 1. So this one gonna be -1 times 1 plus, okay, this one plus. So this times this. Okay, so become 4 times 3 plus 4 times 3. And then this again, this second row times the second column, so become -1 times 2 plus 4 times 4. So become -1 times 2 plus 4 times 4. So then we simplify, final simplify here. 2 times 3, no, this is a 1. 2 times 1 is a 3. 3 times 3 is a 9. 2 times 1 is a 2, correct? This 2 times 1 is a 2, and plus 9 become 11, correct? And then you just simplify, and this one gonna be 4. This 12 become 12, 4, 16, right? This one 12, and this one 4, become 16. Now this one -1 plus 12, so we have 11. Take it out, -1. This one 16, take it down, -2, become 14, right? So this is the final answer for A times B. Okay, for A times B. Then you can check, you can do by yourself by use B times A. They will have the different element. Okay, you can try it. So when we do multiplication, one more, we review one more here. Oh, I don't have space here. Here, when you can time it, that means you see for this one, right? A here. The order is what? Can I erase here? This A, B, okay. So you see this matrix A is what? Matrix A is, this one is a matrix B. This one's a B, okay. This one B, this is A. So this answer, this one should be BA, not AB. And related one should be BA, okay? Should be BA. Matrix time BA. Okay. I cannot erase it, otherwise the computer will erase the whole thing. So this one matrix B times A, this is a B times A, okay, equal to this one, this is a B A, not AB. Then you can try by use A times B, they will have the difference. Now what I try to say, when we are, when we can when we can do the multiplication, whether or not we have to check the order for each matrix. For example, matrix B here, we have how many order is two row, two column. So then 2 times 2. And this one also have 2 row, 2 column. So 2 times 2. So if you find out the first matrix here, 2, and this one 2, if they're same, if they're equal, then you can do multiplication. You can do multiplication for these two matrices. Okay, and then you answer, the answer, find out when you got the answer. The answer have to be this one, 2 times 2 at the back here. So that means when the answer come out have to be, or the order have to be 2 by 2. So you see this answer B, matrix B times A, this is a 2 by 2, correct? Then should be correct, should be right. But only make sure when you multiply here is correctly. Okay. So I think that's all for the multiplication. If you forgot, right? I review this a little bit, but then you can practice it. I will give you some question to practice also. How to multiply. Again, when you do the work for the multiplication, I know you can use calculator, but you have to show the work like this one, they multiply and get 1 by 1. You cannot give me right away for the final answer for this matrix. When you do the multiplication, you have to show the step. You cannot get, I don't accept you get right away from calculator unless that question really complicate the number, then allowed to do so. But right now I just want you just recall and practice first how to get the answer by manual. Okay, now we go next example. I think next one, expand and simplify where possible. If question A, matrix A plus 2i, matrix A plus 2i, the whole thing power 2. Okay, so in this case, expand it. This one actually, you can think about the formula A plus B, the whole thing power 2, right? But sometimes when you use this one, have to careful also because they are different from algebra, right? But in this case, still easy to accept it, right? If this one, just say we expand. If you use this formula, right, you're gonna have a square plus 2 have to be in order. Okay, we use matrix. It's gonna be 2a times 2i, correct? 2ab. If this a, small a, this small b, and then plus 2i, that is 2i and the whole thing power 2, correct, from the formula. Then this one gonna be a square. Scalar times scalar. Scalar can move around, right? Doesn't matter where they are, because this is a multiplication. So 2 become 4. But AI and IA, for the identity with the matrix is okay. From the previous, we already say, remember, identity I equal to IA, which is equal to A. Okay, for identity is okay. But if you time AB not equal to BA, okay? So then this one you can write, this A come first, we keep in the order the prefix multiplication. And then this plus 4, 2 will become 4i squared. Oh, we cannot write down this one. So you can see I's identity matrix. No matter the power 2, power 3, they still come out, still equal to I's. Okay, so it's always equal to I. Okay, then we can simplify next. This one gonna have a square plus 4 and ai equal to a, correct? So we have 4 here and a here plus 4i. So the final answer gonna be a square plus 4a plus 4i. Okay, if you don't use this one, but this one have to concern when you use, okay, sometimes may not same because depend the matrix. But now I use it because it's an I, so I can do it. It become another matrix like a 2b, matrix B. You have to be in the order, okay, don't forget. Otherwise, or from that one, we can do by, say, from the question, right? A plus 2i, the whole thing power 2, we can write it down as a plus 2i. Okay, we can write this one a plus 2i and then time a plus 2i. Okay, and then you can use the prefix time. So this one you can write down as like this one a plus 2i. Oh, I don't know, ball pen cannot write very well. And then time a, and then plus this time this two bracket and this time this two bracket. Okay, so become a plus 2i and time 2i. Okay, after this, because you see then a time here, so this a should be at the back of this a, but when they're the same a anyway, so this one time become a square, right? Plus 2ia, and then plus again this time in here, become 2 is a scalar, can move a lot, doesn't matter, become 2ai, plus 2 become 4, become I square. So we simplify final, become a square. ia equal to ai equal to a, so become 2a. Plus also ai equal to a, so become 2a. Plus 4i, I square mean I, okay? So then we have a square plus 4a plus 4i. Okay, so then you see this can get the same answer, okay? So you can do two way by using this, but this one, when do some cases may not follow exact, okay, unless you have to in the order, okay, which one come first, which one come later. But if you this way expand it by use the commutative properties, okay, like a period, we just compare the algebra, ordinary algebra and the matrix matrix algebra, that one. Okay, now we go next example. For this one, the second one. Actually, the second one is a similar, right? But now become matrix A, matrix B. So we have power 2 also here. So again, you can use the formula there. But in this case, see, if you use the formula, right, the answer at the beginning may not work for here now because they have negative sign. And also matrix A and B, they're different matrix. Because when you time have to be have matrix A, matrix B, right now not same. So in this case, better use by this way better. Okay, we first better do this way, the second way here. So we again we can use the same this one, right? The same idea. So the solution gonna be A minus B. Okay, time A minus B. Because from here, right? From here mean this one two matrix times each other. Okay, so then you can use this one. like a before, right? So A times this one, so become matrix A minus B times A, and then minus matrix A minus matrix B times B. Okay, now simplify, become A is what? A power 2. And this one become minus, don't forget, this A is at the back of the matrix B, so have to follow the order. B come first and then BA. This time in. Then minus, this one B time here. So it should be minus AB. Oh, cannot write. And then this minus become plus and B squared. Power 2 from matrix B. So now you see, this is a final answer for this one. Again, remember for the one I keep saying A times B not equal to B times A. So in this case, you cannot combine, okay? So you leave this one as the final answers. Okay, that's why in this case, I won't use this formula because they will we get the long answer, become the middle term gonna be 2A times B, correct? So we don't use this formula. You can use this formula, okay? Because they won't be equal. This one can use for this situation because this one explained to you here, right here. Okay, so now we go next example. Now in example say if matrix A square equal to 2A plus 3I. This when like I is the I identity, okay? And A power and then find A power 3 and A power 4 in the form of Ka plus Li. I identity. K is a scalar, L is a scalar, A is a matrix. I is the identity matrix, where K and L are scalar. Okay. So in this case, how we find KL in the form, let's say here, in the form of Ka plus Li. Right now, this form is a linear. Okay. This one is a linear form. It's equal to in a linear form. Linear. Linear. Okay, this is a linear form. Okay. So we gonna find scalar K and L. From this, we want to find A square, right? Solution. A means A cube. A cube, I can break it down, become A, make a matrix A, I always say vector. Matrix A times matrix A square. Why? Because we have A square here, matrix A square, so we can replace it in there, inside, right? So this one gonna be A and replace A square become 2A plus 3I. Okay, then we simplify. Simplify it. 2A square plus 3 scalar can be anywhere, okay? But I now time this to be AI. If in this case you like AI or IA, still okay because they're equal to A. But if this identity, this position become another matrix, you cannot swap, okay? Have to be in order, I say again, okay? So then this one become 2A square plus AI mean A, so become 3A. Okay, so we have this one 2A and this one is AI is A, right? Now become 3A. Then this one again, we gonna simplify in this pattern. How we do next? Okay, just repeat this one again. Because we have this A square equal to this, we do it, redo, just substitute inside. Okay, can I? This one gonna be to replace 2a plus 3i, because this is a square equal to this one, right? Then plus 3a. So we simplify, this one gonna be 4a plus 2 times in, right? This one, the property we just saw from previous example. So 2, 3 becomes 6i. And this one plus 3a. Then we simplify, become 7a plus 6i. So this is the answer for a cube, matrix a cube. Okay. So now next we do find a force. Okay. How to find the a force here? A power 4. So again, you can use this one. We can use from this one, right? We can write it down, expand become a times a cube, because we know answer for a cube here. Or either way, or you can use like a square times a square, correct? Because we have a square here, a power 2. So you can either one you can use. But if you use this one, right, a times a cube, make sure this one you get the correct answer. But if you get this one long, right, when you replace here, the whole thing going to be long again for the next question, like a force. So if you do this one, maybe sometime more safe. But again, you can try this one, okay? But now this one, because this one I know is a correct. Okay, so we just replace this one. A times a cube, we have 7a plus 6i. Then simplify it, becomes 7a squared plus 6ai. I will write the order even they are equal. So this one gonna be 7a squared I have here now. I replace again. So become 2a plus 3i. And then plus 6ai equal to 6a, correct? Because ai equal to ia equal to a. Then simplify. Time within 14a plus 21i plus 6a. Then simplify the right terms. 14, 6 become 20a plus 21i. Okay, so this is a final answer for a force. Okay, so now this matrix A, we don't care it's going to be 2 by 2 or 3 by 3 or 4 by 4, because question say nothing, but they just want you work and live in that pattern in the linear form. You see this right now, in this case, that's like a A4. Can we answer K equal to what? For this case, K is 20, correct? And I is what? 21. I mean L equal to 21. Okay, then this is a linear form. It's a power 1, right? They call linear pattern. So this is the scalar of this one. For in this question K is 7 and L equal to 6. Okay, so if the answer for scalar. Okay, so we go next example, more example. Okay, then this one. Find constant, this is A, okay, this one A. And B such dash matrix A square equal to A. Right now, I like this one. I like to use A. This is A small a is a scalar, okay. Plus BL, this is L. For A, for matrix A, equal to this one, 1, 2, 3, 4, the element inside A equal to this one. So find the constant A and B such that this equal to this. How to do? So try to get the information they give to us, this one, right? This one, we have this one. So we write down from A square, but we have matrix A equal to this, correct? Matrix A equal to this one. So but A square, so we can have the solution. Get matrix 1, 2, 3, 4 time, because A times A, right? A square. This is a A, this is a A also. A times A square equal to small a, scalar A. So scalar A, we don't know, like unknown. So matrix A, we have 1, 2, 3, 4 plus B scalar B unknown. And B, or this one not BL, this one, sorry, it should be, otherwise cannot find. This one BI, this one BI. Okay, can I correct here? This is a BI, okay? BI, this one wrong. This is a question. So BI, I is identity matrix. So what gonna write down for identities? So in this case, I gonna be, the order is what, 2 by 2. How we know from here? Because it's on 2 row, 2 column. So gonna be, I gonna be this one, 1, 0, 0, 1. So you replace I here. So 1, 0, 0, 1. When questions say identity and they say nothing, did not give in this pattern, you just see what the information they give to you inside the question. Then you know it's a what kind of order of that identity. So now in this question, we know this is a 2 by 2 because here 2 by 2, 2 row, 2 column. So we write identity in 2 by 2 here. Okay. So after this, then we simplify now. From this, now we can use multiplication again, like before we just say, right? Low. This multiplication, we can check this 2 by 2. We can time. Okay. So if you have different, for example, let me review this one. If we have like this, maybe this, if they have different order, I'll try to get that one. Like this one. If my, for example, matrix A, maybe 1, 2, 3, like this, 4. This is A, okay. For example, time with the matrix B, maybe maybe 4, 5, 6, and then this one 7, 8, 9, and this one maybe 1, 2, 3, like this. Okay, so observe this one, right? This one 2 row, 2 column, right? For matrix A, 2 row, 2 column, and this one is what, 3 row, 3 row, 3 column, or even you have 2 columns. So you observe here. This one 2 row, 2 column. This one 2, right? The column of the first matrix and the row of the second matrix. This is matrix B. This 2, this 3, they are not equal. Then you can multiply it. So this is a no solution. Okay, this is a no solution because this one's a 2 by 2. 2 and this one 3, they are not the same. So no multiplications. Okay, unless this one the same column, same row, then you can do. And then the answer should be this one for the answer. But this one we check already, they are not the same. So no no multiplication. You cannot do it. So just say no solution. Okay, just say no solution. The reason is they have the first, the second, the order of the second, the order of the column of the matrix A is not equal to the number, the row of the matrix B. Okay. Then I think now we come back to do this question. This one we can do correct because we can check this one how many we have, 2 row 2 column, and this one also 2 row 2 column, and then you see this one same, right? Then we can multiply, and also your final answer come out should be 2 by 2. That's the result. When you time it should have the order 2 by 2. Now we start to multiply, to do the multiplication for this one. So first row time with the first column. So 1, 1, 2, this one, and 1, 3. So 1 times 1. So 1 times 1 plus 2 times 3. And next, first row with the second column. First row with second column, 1, 1, 2, 2, 4. So 1 times 2. So like more space. This time this, so 1 times 2. And plus this time this, plus 2 times 4. Like that. Then the second row here, 3, 4 times with the first column, 1, 3. So become 3 times 1 plus 4 times 3. So this one become 3 times 1. 3 times 1 plus 4 times 3. Now next element. First row, second row, second column. So 3, 4, 2, 4. So 3 times 2 plus 4 times 4. So 3 times 2 plus 4 times 4. So now this one gonna be like down here, 1, 2, 3, 6 plus 1 becomes 7. And this one 2, and this one 8 become 10. This one is 3, 4, 3, 12, 12, 3 become 15. This one 16, 16 with the 6, 16 with the 6 become 22. So we have this simplified from A times A here. A times A. Okay. From this one for the right hand side, you just time the scalar inside the bracket. Become A, become 2A, become 3A. And this one is what? 3, 4, right? Yeah, this number 4. So this one become A, 2A. This one become 3A. And this one become 4A. Plus just times scalar inside. So become B, 0, 0, B. Okay. Block the line. Now we simplify this. After this, same location, same. This is the first row, first column, first row, first column plus become A plus B. And then this is a first row, second column, first row, second column become 2A plus 0 become 2A. And this plus this become 3A. This plus this become 4a plus b. So like the matrix pattern. From this left and right, you see the identity. So from 7, the same location with the a plus b. So become 7 equal to a plus b. And 10 equal to this one, 2a. And 15 equal to this one, 3a. 12 equal to this one, become 4a plus b. Okay, so then from this equation, you can solve for AB, and then you get the answer AB. Okay, use a whatever you have here. So, okay, simplify it. This one, what we have, this is an easy one. So A become 5, right? So we have here A equal to 5. When you have A equal to 5, you replace here, you get B. That's all, okay? So B, you get B, 5. B is what? 2. So that's the answer. Okay. So when I think that's all, and then you want to check this two from the left and the right equal or not. You just replace A, B there. This one should have 7, and then replace A here should be 10. So it should be same with the left hand side when you replace A and B in the right hand side. Okay, so this is the answer now for final answer. So I think that's all for today, and then I will give you handout also and the assignment you have to do. Okay, so I think that's all for from now, from this period. Okay, see you next time. Okay, bye bye. You have a good day. Bye.